Okay, the third section of Chapter 1 deals with graphs of functions. So if we're given the graph of a function, remember the domain would be all of the x values. So this is the x-axis, so our domain would be from here to here, all of these values. So in this case, it would be from a -4 to a +3. Now to write your domain, you would write a -4, a bracket because it's a closed circle, so it includes a -4, then a comma, and 3, and this would also be a bracket. Then the range for a particular function would be the y values. So now we're looking at the y-axis, and that runs from that coordinate all the way up to this one. And so in this case, our range would be from a -5 to a +4. And again, because it includes those points, when you write it, you would use bracket -5, comma, 4, bracket. Looking at this second function, in this case, our domain, because it has arrows at the ends, continues on forever and ever in both directions, so it would be all reals. And we would write a -infinity, comma, infinity, and this would be a parenthesis because it doesn't include infinity, because infinity isn't a number, it's a concept. Then our range for this particular function would be anything above this point, and also including this point because it's a line running right along there. So that's a +3 to infinity. Parenthesis on this end, a bracket on that end for the range because it does include a +3. Now then, this particular function is just going to be used to show some different parts of what a function could have. First thing would be in this part of the function up to this point, this is an increasing section of the function. From this point down to here, it is decreasing. Then it is increasing again. And then at this point to here, it is constant because it's a horizontal line. And then finally, we are increasing one more time. Now, some questions will ask you to determine in which intervals the function is decreasing, increasing, and constant. So we would say it is increasing from a -infinity, because an interval would be with the x values, from a -infinity to whatever this coordinate is right here. And we'll say it's a -8. And here we can just put parentheses because it really doesn't increase at a -8. It is also increasing from this coordinate, say 1, all the way over to here, which is approximately 8. So then it's also from 1 to 8 it is increasing. And then again from this coordinate, which is about 15, to infinity. Then our function is decreasing from a -8 to a +1. And that's the only place it's decreasing. And then finally, it is constant from a +1 to a +15. Or not a +1, that would be a +3. Or actually, no, a +8 to a +15 from this coordinate to this one. Now, if we have a function that does something like this at the end, say it comes here, goes like that, and goes like that, that would be increasing on this whole interval. Some other points that you need to understand, or different parts of this function that you should know, would be this coordinate right here. This would be considered a relative maximum. And it's a relative maximum because it is the maximum on this interval. And then this coordinate here would be considered a relative minimum. And it's a minimum because it's this lowest value in this interval. If we had, and because this function goes down on this end and up on this end, there is no absolute minimum or absolute maximum. If we had a function, say, that did something like this, where everything is going down, well then, let's say we put that point would be a relative minimum or maximum. This coordinate now would be an absolute maximum, because it is the largest value, y value, you can get throughout the whole entire function. But when you have one end up and one end down, there would be no absolute maximum or minimum. Finally then, for today, we can classify functions in two different ways. One would be as an even function. An even function, if you substitute a -x into the function, you will get the same function back. So f of a -x equals f of x. And so to show you how this works, take this function, and if you figure out what f of a -x is, you would get a -x squared plus 4. Simplifying this then, a -x squared is the same as x squared, because when you square a negative you get a positive, and you get x squared plus 4. Since this and that are exactly the same, it is an even function. Now if you look at it graphically, x squared plus 4 would look like this. And an even function can be folded on the y-axis. Or it's symmetric to the y-axis. And since it is symmetric to the y-axis, if you have a coordinate, say x comma y, say over here, both positive, then there's also a coordinate of a negative x comma y over here. So like if you have 2, 6, then there also has to be a negative 2, 6 as a coordinate. That would make it even, and that has to happen throughout the whole entire function. Then there's an odd function. An odd function, if you figure out what an f of a negative x is, that will equal exactly the opposite of what f of x is. So here's f of x, and if we substitute a negative x into this, you would get a negative x to the third plus 5 times the negative x. And when you take a negative and cube it, you would still get a negative x to the third. And then the 5 times the negative x would be minus 5x. So this is what f of a negative x is. And now you then also have to figure out what the opposite of f of x is. Which means you have to take the opposite of the whole entire function, x cubed plus 5x. And when you distribute the negative to both of these, it becomes a negative x cubed minus 5x. And now this and this are the same. And so since they are the same, this function is an odd function. Now when you look at an odd function, it could be something like that. Or possibly even something like this. Either way, if you have a coordinate xy on the function, and here we're looking at the green one, let's say this point right here, then there is also a coordinate of negative x, negative y. So for example, if we have this point here that is 3, 2, then there has to be a coordinate of negative 3, negative 2 on the graph as well. If it is neither one of those two, if it's not odd or it's not even, then there is no special name for it. It's just neither. And that concludes our lesson on section 3.